Quick start steps, Studio 5000 and auto instruction. I'm back, folks. Hello everyone, I'm Roberto Cruz and welcome back to RTF M. And we're continuing on our endeavor to RTF M in the online help. So we're going through the quick start steps. The last video where we discussed about on UDTs, how you can configure your own UDTs, user-defined data types. So that was to set out the encapsulating the function block subject that was coming. So in today's video, we're going to talk about add-on instruction, which is basically a continuation on what we've discussed on our previous video. So you can see, I'm going to place a link to our previous video somewhere here so you can access the UDT video. All right. First of all, as you may see in my background, guys, I'm still on the road. I have been very busy, so I apologize for not being able to cope. So I think it's been about 2 weeks since I've posted a video. So really sorry about that. So I'm hoping to keep consistency from now on, and so you can crack on with Studio Logix Designer, because there's so much to cover on this subject. So hopefully we can catch up and then post videos twice a week. My plan is always to launch on Tuesdays and Fridays, right? So if you guys apologies done. So if you guys wanted to catch up and get in touch, just follow us on Instagram. Make sure you follow us in there, DM us. We always respond, right? Is our main social media, if I would say so. So it's the one that we've been actively posting daily, right? So you can always find us, the link on our description of these videos. So if you want to browse, it's at RTFM, at RTF_M. So you can follow us on Instagram, right? So without further ado, guys, let's just dive into the add-on instruction world, right? So before I switch screens, so I'm not going to talk about add-on instruction in depth because this is the quick start steps. So there is a special manual for it, which we're going to be covering in the near future. So this is just for you to be able to understand the basics to create an add-on instruction. So we're going to create an add-on instructions together, right, ourselves, so I can show you guys how it's done. Okay, so let's just switch screen and dive into the add-on instruction world, right? So this is an add-on instruction. Just before we do anything, I just want to show you guys. This is basically a function block diagram add-on instruction. I've designed this from scratch. So this is a pump and add-on instruction for you to be able to control a pump. So you've got a couple of inputs here, a couple of outputs. You've got the add-on instructions name, which is called pump B. I called it pump B because I had designed one called pump A. So pump B, and this is your tag name. So if you want to copy this and reuse, which is the whole purpose of using add-on instruction functions, you can just copy and replace and rename it. So it's already renamed as pump 2. If I just right click, for instance, if I right click and obviously create a new device, you can always create a new element by right click or use the shortcut Control W and create a new type. Let me just delete that because so this is add-on instruction. So this is where the logic sits. So we've got the parameters right here. So I can show you briefly. So this is where you've got your tags, right? So you've got your definition. So this is where this is pump A. Sorry guys, let me just go back here. Pump 2, pump A has got nothing in it. I've started it, but just moved to pump B. So these are all the tags. So you've got the parameters, local tags, scan modes. So so it's your signature if you wanted to protect your add-on instruction, your revision control. So it's always in there, right? What else? We've got the logic. So basically the logic, the add-on instruction is comprised of 2 routines. I've got the main routines called just logic and pre-scan. So pre-scan is a special one that you can pass. You know, this one is basically, as soon as the PLC runs its first scan, it will set up a few parameters, like a default parameter. So this is available when you create your add-on instruction, right? It's one of the features of it. And obviously your main logic. So that function block diagram is basically contains all those lines of code, right? So these are code that, you know, this is a code that I've designed for you to be able to control a pump either manually or automatically via HMI. I'm gonna try, this is one of my plans actually. I'm gonna try to create a new, you know, a repository so we can have a sample of codes for you guys to be able to download it. I think you can do that on GitHub or something, GitHub. I'm gonna try to create an account there, and as soon as it's available, you know, I'll obviously I'm gonna let you guys know, you know, either via our Instagram page or over here on YouTube. So follow us on our social media, and you'll find out once these samples are available. I'm gonna do my best to make this happen, you know, ASAP. Right, so this is the logic that sits on the add-on instruction, and this is the add-on instruction. So let's just create a new one, right? Let's just create a new add-on instruction ourselves. So a couple of things I'd like to mention. Obviously, let's just, so over here, let me just zoom in so you guys can gonna see a little bit better. So add-on instructions, right? Like I said, just a couple of things I'd like to mention from the manual, which I think is useful, right? So, for instance, add-on instructions, like I said, are use-defined instructions that are used to contain commonly used logic. So, repetitive logics, basically, as set of instructions. So this enables you to easy reuse them, these instructions in projects, and obviously makes your project consistency, promotes consistency to your project, and obviously it speeds your developing. So it helps your project development, right? So you can use only 3 languages in logic design. So you can either use standard ladder logic, a function block diagram, or structured text to be able to design your add-on instructions. So you've got source protections, which gives you, you know, the possibility of set your inputs or an output parameter to be read-only, and obviously preventing your external access, like from HMIs or every other, you know, communication device that sits in the outside world to access it. So you can have that option. So it prevents obviously unwanted changes. It protects you to your intellectual property as well. So you can set, you know, the source protection to be able to, you know, to seal it up and, you know, seal up your logic, and obviously no one would be able to modify it. They can still use it, but they wouldn't be able to modify anyone, you know, without having, you know, any of the passwords or signature IDs. They wouldn't be able to actually modify the logic, right? It's available for saved PLCs as well, which gives you an extra signature ID for your safety instructions. So it's a powerful tool, really. So let's just create a new one then. So over here on the controller organizer, so if we select controller organizer, so we get a new instruction, we're gonna create that in ladder diagram. So, and I'm calling this pump. Actually, let's call this simple pump, right? So data type, like I said, you've only got 3 languages available, either ladder logic, function blocks, structured text. You got your revision control, you've got your revision node. So let's just say this is the first issue, right? And obviously, as soon as you hit OK, it's going to open the logic routine and open the definition pop-up. I'm going to untick that so you can open up the logic routine as soon as we hit it. So you can push OK and you're ready to start writing down your code. So here we go. So this is a blank page, so we can start like configuring our devices, right? So let's just quickly create a logic. Let's just start and stop motor, right? So for instance, like a branch start, normally open, a next branch, another normally open. Branch ends, we've got a normally closed. We got an output energized. And here we go. So this is the first bit. So let's just have another line here, very quick. So we got another branch start. And this time 2 normally open. Next branch, we have another 2 normally open contacts. Branch ends, and we have an OTE, energized. Oops, that's wrong. Let's just start it again. So, oh, that was a complex lot. Check this out. So branch start, we have, BST, right, which is branch start, normally open, next branch, and normally open, right, branch end, and then we have an OT. Here we go. This was what was intended to do, right? Here we go. So what we have is a start. Let's just create a start, very quick, stop. We have here, I'm gonna call this manual request, right? And we're gonna use this to latch. So if you're familiar to old school control relay logic, so this is how you normally would do in by wiring, via relay or contactor. So you would have 2 external momentary push buttons. So 1 star normally open, 1 star normally close. So as soon as you push that button, you energize your relay. Your latch bit, your relay is going to close, an auxiliary contact would shut, obviously, and then as soon as you release the start button, your current it would flow via this circuit, and then as soon as you push stop, you open up the circuit, you cue this, and you would turn off your pump. You see, simple stuff, old school. There is latch and unlatch, but this is just for the purpose of showing you guys other instructions, right? But for those of you who never been on the tools like wiring, I came from the electrical, background. So, this is something that I've done, 20 years ago. You know what I mean? So it's nice to mention. Right. So our manual. So over here we're gonna have our auto request. Let's just create an auto request, right? And actually, let's call this auto request input. We can drag this. As soon as it turns green, see, you can just accept it. So this is going to be our auto request. So then we have now here our manual request. We've also got auto request. All right. Also, let's just move that, and there's that. Right. So over here we've got our manual key, like manual mode. Let's just call it manual mode and auto mode. So it would be pretty much like a selector key. So where you can select modes. And finally, ultimately, we have our pump motor, right? So, and this is a simple logic, right? Simple logic. So let's just now define see that you got, a cross here, like a red cross. So this is a red X. So this red X, it means that something's wrong. So if you compile, it's gonna issue you an error. It's gonna announce an error. So what we do is we define that. So this is where it comes to the definition, right? So Control W, or you can either select either new parameter or new local tag. But if you just use the shortcut Control Tab, it opens up the definition. So obviously you have to select the tag name, which I didn't. Here we go. Start. It's a local tag. It's going to be an input parameter. So input allows you to alias it to a physical input. We're not going to do that right now. It's just for the sake of show you guys how you can create that. This is a Boolean, right? And this is obviously worth mentioning. Like I said, it gives you can select your other instruction to be protected, from the outside world, like an external access, such as a HMI. If you don't want your HMI to access your inner function block, you can select read only for instance. But we're gonna leave read write in the meantime. You can select the style. Just leave decimal, and you can either select visible, or you have to select visible because it's an input. But as soon as you hit required, it selects visible automatically, because if it's required, it has to be visible. All right. So input parameter, stop. It's going to be the same. So we got stop local tag. Sorry, not local tag. This is input parameter. We're going to make it required. Right. this is now a local tag. So basically a local tag, you see that all of those, all of those fields are grayed out. Is because as soon as the local tag is only used within the function block, no one else can have access, unless they wanted to change and modify your function block, your add-on instruction. So I'm going to be calling it add-on instruction, right? But you forgive me if I say function block, because obviously it's a function, but it's called add-on instruction. Anyways, let's carry on. So this is a local tag, and you see the error is gone because you've also got a manual request around here. Oh, this is going to be an input parameter. So let's set to input parameter, and it's gonna select required. Auto requests. Guess what? Another local tag, because it's just an internal memory. Manual mode. So manual mode is an input, right? I'm only gonna make it visible. Oh, actually, let's just make it required. So let's just make it required. And auto mode is also an input, right? And we also going to set it to required. And ultimately, pump motor, which you guys might be guessing, is obviously an output and is required. And I'm setting to. I might have set the other ones to read only. It's not going to affect the purpose of what we're doing now. And here we go. So no more errors. You see? So this is it. Simple as that. So if you want to change, right click in here, open definition. So that brings you the instruction definition. And you can always you see this, there is a moving down position. I'll show you in a second what does that mean. So but basically, this is where it shows all your parameters. And you can turn it required. You can set default values. So if you want a certain memory to start to a certain value, you can set it up here as initialized. As soon as it's initialized, you can make obviously your enable in, enable out like an extra safety level. So if you wanted to enable your instruction upon a certain condition, you can use that. You can select it here, right? What else? Your local tags. So this is where your local tags, which is only available within your function block. So this is where the scan modes, the special scan modes. Remember when I showed you earlier, we had the pre-scan on my function block where I was passing parameters. So this is where you can have either a pre-scan routine, you can have a post-scan routine, and you can also, this only works with CFCs, right? Sequential function charts. And you've also need your enable false routine, enable in parameter if it's false. So you can have a routine if a certain condition is achieved, like if you're using enable in, enable out, you can run a certain routine if those conditions changed. Signature. So this is where you protect your function block. We're not going to go through this. This is going to be part of the future content on add-on instruction from the add-on instructions menu. So once we are RTFMing, I'm sure this is going to be part of it. And your change history, your control revision, if I may put that way, your control revision bit. Here we go. Lovely. Your routine is ready. So let's just place your routine into a logic, right? So let's just place it in here. So if you select add element, so remind that this is function block diagram, right? And now if I type simple pump, you see it's right here. Take a look at it, how beautiful it is. This is our function block. So we've got start, stop, remember that. We've got auto request, manual mode, and auto mode, right? Let me just show you guys a couple of bits. So if I right click, right, and open up, oops, not these, right? Hang on a minute. So I think it's easy for us to be able to go via the actual instruction. So if you open up definition, right, do you remember that? I think if I drag that, you'll be able to see it. So parameters, if you select one of the parameters, right, let's just select one of the inputs. So start. So this is the move up and move down, enables you to drag your inputs to where you think they fit best. So if I want my stop to be on top, this is it. I'll make it. Another bit is like visible. If I don't want to auto request, for instance, don't want auto request to be visible, I apply that. As soon as it applies, what it does is it tells you how many function blocks are being used. And then as soon as you hit yes, it's going to accept the changes, right? So I'm going to hit yes, and you're gonna see these function block change, right? So check this out. You see, here we go. So we no longer have, the available, visible, the auto request input visible. I think I've made it required. That's why it's still there. And obviously your stop is has now moved up. You can see here there is an error. The error is due to, if you don't have something connect to your logic, the error is gonna stay there, right? Let me just show you briefly, so how you can, because it's obviously required. So if let's just close these down, so for you guys to be able to just see the error, going away. So input reference. It's going to make it there, right? Actually, hang on. Let me just copy. Let me just copy this so we can. I just wanted to show you guys how it works really. So if so start and stop, and I'm gonna make. I'm gonna add all. Like, I'm just gonna link them all up. I just wanted to show you guys how you get rid of this error, because basically, because you've turned that you made those signals required, the error comes up. If you set your input parameter, either your input parameter or your output parameter to require, it won't disappear. You see, when you connect to a certain because this is a physical output, you cannot address them twice. It's going to give another one. You see, error's gone, so it's now compiled. So this is how it works. So for instance, I remember that we've changed. Let's see. Yeah, you see. So auto request input isn't required, so it doesn't give you an error. But if I disconnect this stop bit, you see the error comes up right away. And I'm just Control Z. So we can get back to this stage. So this is our beautiful other instructions. So we've created one. So if you have a simple pump that you wanted to control like via either manually or automatically, you could use this simple logic and then reuse that throughout your code. So this has been a long video, guys, 23 minutes. So I reckon we actually. I think we are wrapping it up now, the quick start steps. So the next couple of steps is going to be, we're going to dive into the Logix designer tool. So we're going to go through navigating through the application toolbars. We're going to try to understand the tool a bit more, right? Configure the appearance, behavior of Logix designer. So this is going to be nice. So we're going to understand components about Logix, the designer project components. So we're going to go through the actual tool. And then hopefully I might be able to add a few bits and pieces throughout it. All right, so let me just come back to the main screen here, guys. So switch. I think we wrapped up the quick start steps. And this is it. Thanks for watching, guys. So likes are much appreciated. So if you really enjoy this content, this video, and if you like operation technology, industrial automation, just, please consider it. Do consider subscribing to our channel, and obviously don't forget to ring the bell to make sure you get notified about our latest videos. So if you really enjoy, make sure you follow us on Instagram. Let us know in the comments any subject that you wanted to see here from the industrial automation world. And again, Thanks for watching, guys. I'll see you guys next time, and always RTFM. Take it easy.